the Hedera Hashgraph is focused on public blockchain and public layer ones. And so if we're talking about blockchains, it helps to reframe it and take a step back and talk about distributed ledgers. So it's kind of the parent category of blockchain. And so if you're looking at the properties that make these technologies interesting, it comes from the fact that you have shared state across parties, you have strong cryptography that guarantees that that state is actually true, that it wasn't tampered with in transit, and that you actually can validate that it's the correct information shared between parties. There's no central point to attack, there's no central failure, there's no central server or operator. Obviously that gets a little interesting when you talk about leader-based consensus algorithms, but there's nuances all the way down in these things. And so the rules in these public networks are explicitly determined by the governance of those networks. And so the governance is a huge conversation when we're framing this around blockchain and distributed ledgers for enterprise. If you have things like Bitcoin having 4 dozen forks that I probably can't even name, it's really going to prevent or at least provide some hesitation to serious players getting into the space. And then they also all require some type of consensus mechanism. So the whole concept is having a shared source of truth and having the same party sharing this data. And so you need unique ways to come up with how to kind of determine which data gets added to the state of that ledger. And so the consensus mechanism is truly the most interesting part of all these things. People are asking, like, well, why didn't you build a blockchain 20 years ago? It's because we didn't have consensus mechanisms that were able to do it in the right ways. And so generally, this isn't a universally accepted kind of framing, but it really helps kind of start the conversations and gets people out there with the kind of options and availabilities there are. So you have different ways that people can actually access the data within a distributed ledger. You can have APIs that your endpoints can allow anyone to read from, or you need specific keys to read from those endpoints, right? So you can control who has access to write and read from this ledger, which provides you a lot of interesting opportunities. But then they also come with flavors of network participation. So adjacent from the actual data on the network, the actual participation in running that infrastructure and sharing the state and having direct insights into what's going on is kind of an adjacent conversation that needs to be approached separately. And so, not just for blockchains, but for all distributed ledgers, when you frame conversations in these ways, it really doesn't matter what you're doing, if it's on a blockchain, if it's on a Hashgraph, if it's on something else. What really matters is what you can do that you weren't able to do before. And so these are really kind of helpful ways to frame the conversation. And so you can take a step back from blockchain and say, how can I add these things to my business? And so from here, I'm actually going to talk about Hedera and what we're specifically doing, trying to enable blockchain, public blockchains or public blockchains alternatives, because Hedera is not really a blockchain, for enterprise applications and ushering enterprise adoption. So blockchain can be thought of one way to build a distributed ledger. You can use proof of work. You can use different types of consensus mechanisms. There's pros and cons to these implementation decisions. One of them with proof of work is that there's no guaranteed finality, right? There's no point in time where you can point to the ledger and say, I know this is the truth. It just becomes increasingly and outrageously expensive over time to actually attack the network and revert that transaction. So you can say, all right, like I'm good with $1 billion of security, but maybe that's not okay for the government, and you're doing state-level actions, right? There's nations out there that could have $1 billion to roll back the Bitcoin protocol. So there's definitely pros and cons. Weak governance in blockchain is definitely seen as a pro. The ability that you can take that network and fork it and do whatever you want. Most of the meaningful work in public enterprise adoption right now is going on in Ethereum, and they're going on in forks of Ethereum. And so Ethereum wasn't built from the ground up for enterprises, it was built from the ground up for public use in this permissionless censorship environment, and these other companies are tacking on enterprise features. And so if you build a network from the ground up for enterprises, you can really do some interesting things. And so yeah, lots of people are using permissionless blockchains, it's super interesting. But there's also other ways to build these types of distributed ledgers. The most common example now being kind of innovated and coming into play are directed acyclic graphs, or DAGs. Notable examples are like IOTA. Everyone's pretty familiar with kind of IOTA's Tangle and the way that it looks, the way that it processes transactions. Is this really interesting graph structure. And with these graph structures, you can do things that aren't possible on blockchains. Hedera by itself processes over 10,000 transactions a second within a single shard, which is orders of magnitude than we know for available blockchain alternatives that offer the same types of security models. And so sometimes these are definitely harder to understand how they work. So if you're dealing with this kind of complicated graph that's growing in history, it's clearly like a less understandable or digestible mental model than just a sequential order of blocks, right? Like you can just say, okay, well my transaction's in this block, that's before this other block, I get how it works. With directed acyclic graphs, you actually have to understand the underlying consensus mechanisms and the subtleties between them to see what makes one directed acyclic graph different from the other. So just to kind of give you a comparison of how this works, you can see on the right there that the hash graph looks a lot like IOTA's tangles if you've ever seen the diagrams. But the nodes in Hashgraph are totally different. Our diagrams represent totally different information than IOTA's tangle or other types of DAGs would. And so they may all look the same, but they're not the same. And I'm not going to talk that much about traditional public blockchains. I think people really kind of know what the pros and cons there are, what people are trying to solve, scalability, proof of stake, environmental problems. Like those problems will be addressed in the future. But Hashgraph is solving these problems now. So basically how Hashgraph works, I'll try to understand it at a high level, but if you want to talk about it in depth, it's one of my favorite things. I'll meet you at the back after and we can dive into it. But basically every kind of circle in this graph actually represents a node in our network. When you submit a transaction to our network, that node will pick other nodes at random and just gossip that transaction out to other nodes. It's the fastest way you can possibly disseminate information in a distributed network, which is a gossip protocol. But what's interesting about Hedera is you're not just gossiping about the transactions, you're gossiping about metadata of transactions, and that metadata is cryptographically signed. So you're not just telling people that I have a transaction, you're telling people that I have a transaction. You may or may not have heard it from someone else. If someone else told me this transaction, they're going to cryptographically sign that message saying that this is coming from me. And so each kind of line in this hash graph is actually a cryptographic gossip about gossip, telling you what the message is, who I learned it from, and when I learned it. So you actually get this incredibly rich, tamper-resistant, secure directed acyclic graph that has an incredible amount of rich information on it. And so every single node in our network has a copy of this hash graph on it, and everyone knows when everyone's talking to everyone else, everyone has a slightly different variation of the hash graph, but everyone's perspective of that history of seeing that linear traceability between the signatures, saying I saw this come from this node, this other person saw it come from this node, we have the timestamp that proves it, and then after you have that, and a supermajority of Hedera's network has seen that transaction, we'll run a virtual voting algorithm. So it's based off the historical voting algorithms that have existed for 30 years that have really strong mathematical and security proofs, but are so inefficient that no one's ever actually deployed one into the wild. But what our brilliant CTO, Dr. Lee Baird, actually invented is a way to do voting in the historical sense, but without sending any votes over the wire. So essentially, because you have all of this rich information on the hash graph, you don't have to talk anymore or send any additional messages on top of gossiping the hash graph to determine a total consensus order. So after you have the hash graph, you have all the information that everyone else has, and you can run these old voting algorithms only with the information you have that's locally on your client without sending any votes over the wire, which is really interesting. You can do over 10,000 transactions a second just for our cryptocurrency service. You get finality within about 2 to 3 seconds right now. It could go up to 5 if a lot more people are using our network. Please come use our network and push it up to 5, that would be awesome. And so it's formally proven to be ADFT. We have a Carnegie Mellon professor who's doing formal methods verification for us. You can download the code program, verify that it's accurate, verify that all the lemmas and the proofs are correct. Check it yourself. It's been out for about a year. But this is what Hedera Hashgraph is all about. We're about being a third-generation public distributed network. And what this means is that you need to architect solutions from the ground up with scalability, stability, compliance, and governance kind of baked into the model. You really need to have these things, not from post hoc, okay, how do we make this work for an enterprise? You need to have it be from the ground up, what do enterprises need and how can we give it to them? So Hedera, from day one, has been trying to systematically address these problems for public networks. And I think we're doing a pretty good job at it. So the first point that's interesting is the Hedera Governing Council. I think this is kind of something we've pioneered in this space, and I'm very proud of it. The Hedera Governing Council consists of up to 39 members globally distributed around the world. They represent up to 18 different market segments. You can only serve 3-year terms and 2 maximum terms. So unlike every other network out there, the core protocol developers, the inventors, the founders, are not going to be making the decisions for the rest of history. You actually have a truly decentralized governance model where members get rotated out, they have equal votes, they have equal stakes, and their vested interest in the long-term success and continued decentralization. And by having such large kind of global Fortune 500 companies on the council, their stake or their ownership in Hedera is nowhere incentivizing compared to their actual core business or their revenues. People join our governing council because they want to build products and use the Hedera network. They want to be involved in determining what goes into the future of this technology. And so hopefully this gives you a sense of what's going on. Today we have 10 members announced in the Hedera Governing Council that are all actively working together, exploring use cases, looking into ways to advance the technology. They determine our roadmap, they determine our token economics, they determine our budget. Basically every high-level decision at Hedera comes through these companies. And some of you actually may work at one of these companies. I'd love to talk to you if you work there and didn't know this before this presentation. And so these companies aren't just partners with us, they legally join Hedera LLC and become a co-owner of the Hedera network. So it's a really big investment that they're taking that actually requires a significant buy-in. You can imagine how long it takes to get technical due diligence and legal approval to do these things and to join a public network. So we're really, really excited to have these companies working with us and actually co-owning the Hedera network. We'll have up to 39, and we're hoping to fill out that council by the end of 2020. It's a super ambitious goal, but we're looking forward to trying to get there. And so now you have a concept of this governance. These companies work together, decentralized over time. Important decisions have to be unanimously agreed by all of them. Less important ones are 2/3. So it's a lot like other things. But the Hedera Governing Council is in charge of the Hashgraph consensus algorithm and these services that we've built on top of the Hashgraph consensus algorithm that make up the Hedera network. So it's basically APIs that you can use and ways to build applications with that leverage Hashgraph technology. And then on top of the Hedera network, you have all these rich third-party applications. We have a really awesome developer community already. We're working with governments that are building on us, nonprofits, companies in like the public-private spheres. We're touching all verticals, all market industries. We want anyone to use us for whatever they want to use us for. And so this is just a glimpse of some of the companies building on us to date. We have over 2,000 developers who have been onboarded and using our testnets actively. I'll talk more about some of the ones that are live in a minute. But Hedera has its own cryptocurrency, like all other public networks. You need something to determine how to charge gas, how to charge storage, basically ways to mitigate spam and DDoS attacks and to prevent malicious actors from controlling or preventing non-malicious actors from using the network. And so Hedera has its own cryptocurrency called HBAR. We can currently do over 10,000 transactions a second per shard. And so we're built from the ground up for sharding. That's a throttle 10,000 transactions per second. We just launched our network about 3 weeks ago. And so we're gradually increasing that throttle as we become more and more comfortable with the performance that we're seeing. We see over 100,000 transactions per second in tests in different environments. But we're being very meticulous and concerned, focusing on providing a stable platform for enterprises to use it. So Hedera is a proof of stake mechanism. So actually in that 2/3 supermajority in Hashgraph, it's not just 2/3 of computers, it's not 2/3 of the council, it's 2/3 of the stake. So the treasury, like the token supply that Hedera owns, the council will actively proxy that or stake that to their own nodes. So those funds held like kind of long term for the next probably 15 years, or getting distributed over 15 years, will be proxied from council members to themselves. but anyone will eventually be able to run their nodes, stake their HBAR to their own nodes, and participate in that actual voting mechanism. We have our own file service, so this is pretty interesting. Cryptocurrency accounts on Hedera are actually parts of our file service and exist on our file service. It's a really great way to kind of reference off-ledger data. So a lot of people have difficulties with trying to get data into your smart contracts. This is a really native way to say, hey, I want you to go to this Amazon S3 bucket, get the data that's there, and use this as this input. It's also a really easy way to do decentralized identity because you have a clearly defined file space on the network. You can actually just add little claims to that are the attributes from your decentralized identifiers. Esther gave a great talk about it earlier and about how you need people kind of attesting to who you are and what you're allowed to do. And this is natively enabled on our file service. There's a lot of other things that you can do on it too. Because Hashgraph doesn't actually require you to store the entire transaction history like a blockchain does, you can do things like revocation. So if you give someone a driver's license on another blockchain network, how are you going to take that away from them? How do you convince them that you can do something else with it? But on Hedera, you could actually take it away if you wanted to. We also have support for all Solidity smart contracts, so anything you're running on Ethereum, anything will run out of the box. You just deploy your bytecode to our files, and then we have an API that'll let you call that file in predefined ways. So anything you're doing on these other networks, you can do on us. It is worth noting that these other services don't have the performance that HBAR does. We're currently seeing about 100. We're throttling smart contracts and files to 10 transactions per second right now. We're seeing hundreds, maybe 1 to 500 file service or smart contract calls per second in testing, and we're methodically speeding that up as well. I was warned I'm running out of time, so I'm going to power through part of this. Recently, about 2 months ago, we released a brand new white paper for a new service that we have. It's a new product offering. It was co-authored by IBM and Brian Gross, who's a principal product manager over there. Those of you that work at IBM might know Brian. But we're very, very excited about this. Read the white paper. But basically, we're offering a consensus as a service. Hashgraph is so incredibly efficient and so high throughput that we want you to use Hashgraph to order transactions in other networks and other applications. So we're actually building an open source integration with Hyperledger Fabric right now that you could use Hedera's consensus service as the ordering mechanism or the consensus algorithm in your Fabric deployment. So it'll be a really easy integration where you just switch what's doing the ordering, and you get all of the public trust of the Hedera network, you get all of kind of the public verification, you get the public auditability, and you don't have to stand up your own nodes for a Hyperledger Fabric deployment. You could actually do a Fabric deployment with just 2 nodes, where you don't trust the other person. The state proofs from Hedera will tell you the information that you need, and you can prove that based on that. So basically, Hedera's will give you the state proofs, which is the total order of the transactions that you need in your Fabric deployment. And based off that, you can update your Fabric deployment, in accordance with this order of transactions. So it's a really interesting hybrid model between the Hedera public network and any type of private infrastructure that you want, whether it's a private database, a Fabric deployment. There's really interesting things that you can do with it. So what's going on? We launched our network publicly on September 16th. This was a really big deal for us. We're really, really excited. Anyone can go use Hedera, create an account, buy HBAR if you want. Not investment advice, please don't do that. But you can go do that if you wanted to for your application only. That's my suggestion. And then we're actively working on getting new council members. Like I said, we're trying to get to the full 39 by the end of next year. We're releasing our open review code base. One of the unique things about Hashgraph is that it's a proprietary and patented consensus algorithm. And so the code base won't be open source, it will be open review. So you'll be able to read it and make sure that it's correct, verify it, but you won't be able to take it and fork it into your own network, which is super interesting. And then the beta availability of consensus service and our integration with Hyperledger. Our product team might not like me for saying this. I hope it's out by the end of the year, but don't make us stick to that timeline at all. And then just to touch very briefly on the developer adoption that we're seeing so far. On day one, the day that we opened access to our network, we had 26 applications already running and live with real users. We're very proud of this, and we were super excited about it. AdStack's is a decentralized advertisement platform doing over 100,000 transactions a day on our network already. Chainlink is integrated with us, so you can use their secure Oracle network. Certara and OpenPharma are doing real-time supply chain pharmaceutical tracking. Hashing Systems is building like basically the MetaMask of Hedera. We have decentralized exchanges, and we have real-time tokenized asset marketplaces as well. Interesting, Beyonce Knowles' dad, his whole discography just got added to TuneFM. So you can now go pay for his music with cryptocurrency. We've already done over 9 million transactions since we started onboarding those applications, and we're doing about 300,000 or so transactions a day, which is about half the volume of Ethereum. For only being out for 3 weeks, we're pretty happy with those statistics. And so ways to get involved, please ignore that the font got changed. I can provide this later. Just go to hedera.com. It's pretty easy. But we also have Twitter. It's all Hedera. It's easy to find us online. And so, yeah, if you want to learn more about what we're doing, if you want to get involved, we're really trying to put ourselves out there. We just launched. We're trying to talk to enterprises, startups, people in the community, whether you're building an end-user application, developer tools. We want to hear from everyone. We just launched. We're super happy to be here. So thank you. I'll be answering questions outside if anyone wants to chat.
Okay, great. So go look up Cooper if you want to learn all